Hello and welcome to, it's already day 7. Can you believe it's already day 7? Anyway, the 7th day of the Electronic Sound Advent Calendar. And before I open up today's, there's some interesting sneak previews here that we actually end up getting 2 breadboards and joining together in what looks like quite an interesting complicated circuit. And I wonder what's on that little green daughter board right there. You see it? And maybe the speaker is off in this box we'll assemble. After 24 days, start exploring the full capabilities of your completed electronic synthesizer. Sounds fun. Right, but what do we get on day 7? Let's open here as it instructs. And day 7's here. Another small one. What have we got here? Oh, got part of the packaging with it. What's that? Oh, right. Day 7 is a resistor. And I wonder, what are we going to use a resistor for? Now, a resistor plus a capacitor, probably this means yet another timing element. Well, this could be interesting indeed. Right. What do we have in the instructions? Day 7. So, today's component is a 15 kilo ohm resistor, and if we look, we should see. So I believe that's 1 and 5, brown and green. No, red is 2. So that's 15 kilo ohms. And what are we going to do? So 15 kilo ohm, as indicated by the brown, green, black, and red rings. And it says reduce the electric current. Yeah, I guess. Or to maybe limit the electric current. They don't really explain Ohm's law. There's been, so far, no math in this particular booklet at all. Okay, so we're going to put it across between this capacitor and this other capacitor. So we've taken away our antenna, and I think here we're making an oscillator, so we're going to get some interesting noises. Okay, well, let's have a go. So here's yesterday's circuit, and we're taking off the LED. Can I put that in view as well? Let's put that in view too. So we're going to take off this LED. We're going to put the LED on where the output of that capacitor is. Now the LED, I think it's got to go this way across, so the long leg goes into that pin there. And let's just disconnect the batteries completely so you can see what I'm doing. Long leg, actually the long leg should be up here, sorry, there we go, like that. And they have left these in place, but taking away this line that is the antenna that we were using the other day to make crackling noises. Again, the buttons are just left. Although we could introduce buttons so we could actually turn it on and off and make it go. But we'll do that maybe later. Maybe I can introduce another wire. Okay, so let's plug in power. Oh, well, hold on. Before we plug in power, let's remember to put in the vital new component. So that goes across here. And look, the capacitor is actually 1 pin up. So we have space to put the resistor across from the leg of this other capacitor. So it's between the 2 capacitors. The other thing we don't have here is a schematic, which I find kind of helpful because this is somewhat tricky to see what's going on. I'm going to break all the rules and I'm going to draw on this piece of paper. I'm going to do that right after making it run. Come on, let's hear it first and then we'll go and draw on it. Right, what do we get? Oh! So speaker is indeed crackling, so indeed it's a low frequency oscillator. And that LED is pulsing something chronic. It's brilliant. Right. Going to disconnect that because that's going to make my brain hurt. What I could do though is if I rewire it here and here, Now it's button powered, which I think is far better than just having it running the whole time batteries are in. Okay, let's see if we can sketch this circuit. So we have, let's have our batteries this way, and someplace we have our LED, and we've got also a line down to our amplifier. I'm just going to draw it as a box for now. So that's our, what was it? It's an LM386, wasn't it? Yeah, of course. Yeah. LM386. Okay. And we've got two connections out from there. One goes to this capacitor. And one goes out to the speaker, which I'm going to just draw as a cone like that. Okay, and then maybe I've not given myself quite enough space there. We'll take that down a bit further so we've got enough space. So, oh, and actually, my bad, that's the resistor. So we've got a resistor there, which goes to the small capacitor here, and before it gets to this speaker it goes across the larger capacitor, which I've probably drawn all wrong in terms of polarity. Okay, so we've got the large capacitor there, got this capacitor here, that goes into a pin like that, and there's another pin like that. Is that right? No. So there is two pins going drawn to ground, not the capacitor pin. The capacitor pin is just a straight through connection. We'll draw a, it goes over. There we go. And so I've added a push button to it. There we go. And now, well, if that is, so we've got what, pins? I'm assuming it's 1, 2, 3, 4, 5, 6, 7, 8. I might be all kinds of wrong, but that would mean that this is pin 3 and 4, 6, oh no, 5, sorry. 5, 6 and 7. So pin 8 is not connected. Pins 1 and 2 are also not connected. So that's the circuit we've actually built. It's not going to make much sense without us understanding what the pins on the LM386 are doing. So I wonder what those pins do. Okay, so let's have a quick search of the web. And we're talking about an amplifier. Normally it's drawn as this kind of triangle shape where this is our output. And we then have inputs here and here. So we have a positive and a negative input. One input is the signal and the other is a reference. It subtracts for the output. And pin 6, it says is, interestingly, it says pin 6 is our 6 to 12 volts. Well, this can't be the same chip. Going to check those data sheets. Okay. So let's draw a box around this. And we have pin 1, which we don't connect. And this is 1, which is gain. pin 2, which is our minus input, pin 3, which is our plus input. We've got pin 4, which is just a ground. Pin 5 is actually the output, which makes sense if I've got this right. So I guess actually what we're saying is that this is pin 1 down here and this is pin 5 up there. So my diagram here was wrong because that's 5 there and that's 1 there, which would make it so that pin 1 isn't connected. Pin 2's input is actually in this case, so pin 2 is actually at ground. Pin 3 is connected to this RC capacitor and resistor circuit. Pin 4 is, as expected, ground. Pin 5, this one, is the output, which both is on this LED and going out to the speaker. So it's going to be pulling the LED down, I guess. But it's also got this feedback through here. So it'll be turning on and then feeding back. That feedback is meaning it's going to pull itself down and then back up and down and back up with the time element. So if you change this resistor or capacitor, you could get a different frequency. So what other things we've got? We've got pin 6, which is our voltage. So that would be this one here, 6, which makes sense. So that's powering it. And 7 and 8. 7 and 8 are bypass and gain, which we don't use. So I guess maybe I have to think about this, but maybe we could reframe that circuit around the amplifier. I've actually sat down and worked it out on this piece of paper here. So this is, I think, the same circuit as below, but with some detail. So it looks like we've got a negative coming in here. We've got the feedback from our output there through this resistor capacitor. Got the LED that blinks, and those are both connected to the capacitor here, the electrolytic, which goes to the speaker. There's our ground rail feeding back. 2 is held low. 6 is just our voltage. So that's the circuit we've actually got. I might later transfer that into this book just as a reference, because I think it's sometimes useful to see what the schematic says is going on. So anyway, I hope you've enjoyed this circuit and a little bit of a dive into turning that breadboard into a circuit diagram, although sometimes I'd kind of come the other way, circuit diagram to breadboard, but anyway. And you've seen a little bit about what's inside this chip with this op amp, well, audio amp more than an op amp, I guess. And I hope to see you for tomorrow's Advent. Go make stuff and be awesome. Bye.